Orange packet. Okay, 6th grade. We are going to at least start chapter 4 today. Chapter 4 is titled Factors, Fractions, and Exponents. The beginning half of this chapter is about greatest common factor, least common multiple, factor trees, monomials, just finding common factors. The back half of the chapter is about exponents, and that includes scientific notation. So this is a very different chapter than what we've done so far this year, and so is chapter 5. These are the kind of like the chapters that are set by themselves. They don't really have any equations or inequalities in them. It's more so practicing factors and numbers, and we're not going to be using the calculator as often, especially in chapter 5. So we're going to just start today with, well, what is a factor tree? You know, what does product mean? How do we find numbers? Prime numbers, composite numbers. So some of this you've heard of, but we need to do an introduction and an overview of it today. Emma M? Yeah, chapter 5 is basically long division by hand, so no calculators. It's multiplying and dividing by decimals, changing mixed numbers to improper fractions, multiplying, dividing, adding, subtracting fractions. So it's a lot of, it's fun. It's a lot of things by hand. Shh, Annalise. We're gonna do this today. We're getting there. Sean? Shh. They probably didn't do equations yet, though. Yeah. Okay. All right. We got to get started, guys. 4-1. Okay, objective is to write the prime factorization of a number. Okay, so we're going to talk about what prime factorization is today. Let's go over the warm-up. Justin? Okay, number 1, Justin, on the warm-up. So 2 times 25? Okay, good. There's a lot of options you could have for these. Charles, what did you have for number 2? Good, 42 times 1. And then number 3, Emma H. Good, 3 and 10. Okay, number 4, is negative 3 a solution of the given inequality? Emma M. Good, that one was true, so yes. 5 and 6, they wanted you to solve and illustrate on a number line. So this was a review from your chapter 3 test. Annalise, number 5. Good, and what's the number line? Good. Okay, number 6, number line, Justin, or answer and then number line. Negative 9. Okay, number line. Good job. Awesome. Okay, questions, Annalise? Should be negative 9 because your last step ends up being 3 less than or equal to negative m over 3. So after you multiply both sides by 3, you need to divide by that negative 1 that's next to the m. Do you see the original problem, Annalise, where there's a negative m thirds? That negative needs to go with the m. So at the very end, you have to get rid of it. Did you forget about it? Okay, hold on. You got to go back a little bit. I don't know what part you're on. Okay, so did you first do 9 minus m over 3 greater than or equal to 12? Yeah. Okay, and then you minus 9 on both sides. So now you have negative m over 3 greater than or equal to 3. And then did you multiply both sides by 3? Oh, I multiplied each side by 3 over negative. Okay, you can. But if you multiply both sides by 3 over negative 1, you get negative 9. Okay. You okay? Okay. Doug? Nope, cannot do that. No, because you're deciding just to multiply this by 3, but what about the 9? If you're going to do that, you have to multiply this entire side by 3 and this entire side by 3. You can't leave out the 9. So that's not equivalent because you're changing the value of the equation, well, in this case, the inequality. So do not do that. Okay? Emma M? Yep. If you want. Yeah. Just make sure you understand why you're doing that. Annalise? Okay, what did you do first on number 4 to get z by itself? Okay, so minus 7z, minus 7z. So you have 6 minus 3z greater than or equal to 11. Did you have that? Okay, minus 6, minus 6. I guess, did you put the negative 3 in first or did you solve it first? I guess I should have asked you that. Did you plug this in first? Okay. Okay, let me go back to the first thing you did. Sorry, I should have asked. If you put negative 3 in first, you should be okay. So you have 6 and then plus 4 times negative 3 is negative 12. So it's really 6 minus 12 greater than or equal to 7 times negative 3 is negative 21 plus 11. Did you have that when you first plugged it in? So negative 6 greater than or equal to negative 11. Or negative 10. Why did I put negative 11? Sorry, negative 10. So at this point, Annalise, negative 6 is greater than negative 10. You can, but you're still going to get the same answer. It's true. So you're done. It's true, so the answer is yes. You can keep going. You're still going to end up with a true statement whether you keep going or not. It's one or the other. Okay? Okay, anyone else? Adam, you okay on that one? Okay. All right, let's go to some definitions, and then we'll see how many examples we can get done. All right, a prime number. Now, this is kind of an interesting concept. It's a whole number greater than 1 that has exactly 2 whole factors, 1 and itself. So a prime number is a whole number greater than 1 that has exactly 2 whole factors, 1 in itself. Anyone know what the first prime number is? This is always tricky for some reason. Sean? Good. Why? Good. Good. What's the next prime number if 2 is the first one? Doug? Nope. Okay. Justin, what's the next one? Good. Matt, what's the next one? Good. What's the next one? Mary? Good. 11. Emma H, one more. Good. We can keep going, right? A prime number, I always say, are the weird numbers. The only factors are 1 in itself. 2 is an even number, but it's prime. 2 is the only even prime number. Annalise? 1 is neither prime nor composite. It's just 1. Okay. 0 is neither. No. By definition, Annalise, for the other one, it has to be greater than 1. A whole number that's greater than 1. It's just whoever discovered this years and years ago, they decided to make the definition of prime and composite a whole number that's greater than 1. So it's not 0, it's not 1. 1 is neither prime nor composite. Charles? Because it has to be a whole number. Yeah. Yeah, I don't know. I'll have to look that up. That's a good question. It's just, Charles, I'm guessing maybe they either didn't discover negative numbers a long time ago when they did this, or they just didn't like them. In geometry, whoever has you for that, you'll do some proofs with these. It won't be a proof as to why negatives aren't prime, but you will do some proofs to understand a little bit more why these are all the prime numbers. Emma H? Yeah. Yeah. Oh. Oh. Well, now you know. Emma M. Yes. Justin. Well, but technically it's not composite because composite has more than one set of factors. So, but it's neither, okay? Neither. I see what you're saying, but neither. All right, composite kind of starts out the same way. Composite number, a whole number greater than 1 that has more than 2 whole number factors. Now again, this is the definition. This is something in math that we can't change. This is just the definition for any math book, for any mathematician, for any engineer. This is just, by definition, this is what this is. A whole number greater than 1 that has more than 2 whole number factors. Charles? We're going to write that down in a second here. Sure. So what is the first composite number? Briar. Good. 4. Who can explain why? Why is 4 composite, Adam? Good. 2 times 2 is 4. 4 times 1 is 4. More than one set of factors. There's 2 sets of factors that multiply to give us 4. That's why the warm-up 1, 2, and 3 were like that, because there's a lot of numbers you can take to multiply to get those results. Okay? What's the next composite number? Matt? Good. Yep. Justin, what's the next one? Good. Emma H, what's the next one? Good. Alyssa, what's the next one? Good. One more. Emma M. Good. ... Okay, composite number has more than one set of factors. You guys have heard of both of these, right? Okay, last definition, then I want to do some examples. Prime factorization. When you write a number as a product of prime numbers. We're going to learn about something called a factor tree at some point today and or tomorrow. So prime factorization, when you write a number as a product of prime numbers. Adam? Yep. Yep. Yeah, I know. Annalise? Shh. M. Correct. Yep. Okay, so for example, 6. Okay, a prime factorization of 6 would be 2 and 3. So you would write 6 as a product of prime numbers, which is 2 times 3. You could also have parentheses around them if you don't like the dot. So all that means is when you're writing something in prime factorization, you're writing that number as a product of prime numbers. Okay, you will hear prime factorization a lot in this chapter and a lot in your book. And the H is the question. Okay, let's wait for that. Okay, any questions on these definitions? Mary, question? You just rewrite it. Yep. Charles? Yes. Yes. You can write them in exponential form. I actually prefer that. Because instead of writing like 3 times 3 times 3 times, like 10 times or whatever it might be, it's much easier to say 3 to the 10th, 3 to the 8th. So yes. Yes. So 2 squared times 3. Yep. We're going to do that. You're just a little... Correct. You're a little bit ahead of me, but yes. Okay. Factor tree. Okay, factor tree by definition is a diagram used to write the prime factorization of a number. So I'm going to show you, which we just kind of already did, what a factor tree looks like. Mary, question? Yes, there's a couple different methods you can do for these, and what I always say when I teach this part is, you know, if you use a different method, feel free to use that, but I am going to teach it by factor tree just because that's typically the most commonly used, and to me it's the most straightforward method, but you guys can use any method that you've learned in the past if you like it better. Yeah, I'm fine with that. So if we make a factor tree for 12, we can, Charles kind of said this, you could start 12 as 4 times 3 or 6 and 2, doesn't matter. So I want you to go ahead and make 12 as an example. And then let's branch off the 6 and the 2. So 12, which is the number that they would give us, is the top of our factor tree. We're breaking it down into 6 and 2. 2 is prime, but 6 is not. So 6 we break down into 2 and 3. Sean? That's what we're going to do. Yep, that's exactly where I'm getting. So at this point, circle everything that's prime, or when you get to it, circle what's prime. It's up to you if you want to do it right away. I typically wait till the end. Once you have all your prime numbers, we write them as a product. So 2 times 2 times 3, which, again, as Charles mentioned, it's better to write it as 2 squared times 3. So we're writing 12 as prime factorization. To get to this, we used a factor tree. Now, this one's pretty easy to do mentally. Some of them are going to get much harder where you are going to have to write it out. Okay, Charles? It's fine with me. Or if it ends in 0, divide by 10. So there are some tricks we'll talk about as we're going through this. Yeah, it doesn't matter. To me, it doesn't matter what you start with. But any kind of shortcuts or tricks you get, that's fine with me. Emma H? Yeah. Yeah, I'm okay with that. Annalise? Yep. A lot of you guys know those in here. I can give you a sheet like that if you guys want, but okay. You know what? I'll get one of those for tomorrow. I have them. Okay. I have one too that's pretty neat and organized, so I'll get you guys one. Okay. Monomial. Okay, hold on one second, okay? Monomial. So here's something different that's added into this math, but possibly not the 6th grade math. So a monomial is a number variable or the product of a number and one or more variables raised to whole number powers. So I'll explain how to do a prime factorization tree with this. So a number variable or the product of a number and one or more variables raised to whole number powers. So when you guys are done writing that, go ahead and put the example as 6x squared. This intro lesson is not that bad. Okay, let's break down 6x squared. I'm going to put our 2 branches on the 6 first and then 2 branches on the x. So what can we change 6 to? So it's a product of 2 prime numbers. Adam? Good, 3 and 2. I'm going to circle them right away because we know they're both prime. X squared can be broken down into what? X squared, Sean. Good, x and x. Can you break x down any further? No. So circle those, they are prime. Now, a little bit different with variables is when you're writing the prime factorization, 2 times 3 times x, the book wants us to keep the variables separate because completely broken down, it's x times x. Okay, now, if you wrote it, because we're going to get into some harder problems like this, if you wrote the x's as x squared, I'm okay with that. But they prefer that you keep them separate because this is as broken down as they can get. Sean? Yes. Variables, keep them separate. Yeah. Yeah. Now, if we had, if this was a 12 and we had the 2 squared, keep it as 2 squared. But the variables, they like when we keep them separate. Again, I'm not going to mark something wrong if you write them in exponential form, but this is completely factored using prime factorization. Kind of bizarre. Well, you mean if it was 12? This one? No, I'm okay with that. Yep, because it's still correct. It's just different ways to write it. Annalise? Because when you learn about something called polynomials, which is going to be next year, a monomial is one term. Okay, that's why. There's a whole nother explanation I can get into, but not right now. All right, any other questions on the definitions? Okay, I wish we had more time, but we don't. I want you to, what'd you say? Okay, good. We're going to do that tomorrow. I want you to open up your homework packet to 4-1. The very first page. Okay, I just want you to try 1 to 24. They're pretty easy, but let me just explain, because even though we only talked about definitions today, 1 through 24. Yeah. 1 to 24 means yes, do 24. But let me explain the first couple. Okay, let's look at number 1. Someone give me a factor. So one set of factors for 28. Emma. Good. So you could write down for number 1, 7 times 4. What else? For number 1, could we write down, Doug? Okay, 14 and 2. What's another one we can write down? Adam. Good, 28 and 1. So write them something like this. That's the answer to number 1. So there's just like you did on the warm-up, you will do that for 2 to 6. 7 through 12, all you're telling me is whether it's prime or composite. So remember, prime, the only factors are 1 in itself. Composite has more than one set of factors. 13 and 14, you're filling in their factor tree. It's kind of interesting. So they basically spoon feed you through it. It's pretty easy. And then on the back, all you're doing is writing a prime factorization of that number. So 15 to 23, I would make a factor tree. Okay, just like we did in the notes on the examples. 24, I only gave you one monomial because I want to do more practice with it. So I gave you one to try, see what you can do. Tomorrow we'll go over this, finish this lesson, and then move on to 4-2. Mary? Yes, yes. I am always okay with that because there's a lot, even when we get to GCF and LCM, there's a couple different methods we'll talk about of how to do it. Annalise? No.